Welcome, students, to another video lecture with Mr. Kenneth. So we're moving on to lesson 2.6, our actual final lesson of chapter 2. I think I have that under control now. Go ahead and pause here and copy down what you see. Please make sure when you write that coordinate plane on the right screen, you're drawing it large enough and using graph areas on your paper to make this function. If you don't have graph paper, you're going to need to use a ruler for this to work, please. So please make sure you're drawing a very neat coordinate plane. Pause here and copy down what you see. Okay, welcome back, students. So in our graphing in 4 quadrants, we're kind of continuing from our chapter 1 lessons on graphing in ordered pairs. Really, the only way we're expanding here is we're going to have to be required to know what the 4 quadrants are. So looking at our coordinate plane, you should notice there seems to be 4 spots. And we want to go ahead and label our vertical axis the y-axis, and go ahead and label our horizontal axis the x-axis. Our line is a little off there. That's going to annoy me. Okay, there we go. Now, the first quadrant on the coordinate plane is the positive area. And we use Roman numerals to number our quadrants. So our first quadrant is quadrant 1, and it's the upper right. Mathematicians, when they started naming the rest of the quadrants, went counterclockwise. So the quadrant 2 is here. And then lower left is quadrant 3. And lower right is quadrant 4. And these are the different quadrants. Any questions so far? Great. Also, you may notice there are no numbers on the coordinate plane right now. So it's important for us, if we haven't noticed it already, when no numbers are listed on the coordinate plane, what do they assume they're counting by? Yes, you're right. We assumed they are counting by 1. It's also important to realize we do not have to count by the same interval on the x-axis as the y-axis. We must maintain the same interval for each axis. So it's important for us to recognize that although we do not have to count by the same number on the x-axis as the y-axis, if we count by 1s on the x, you have to stay counting by 1s on the x. If you count by 5s on the y, you have to stay counting by 5s on the y. So these are some important things for us to remember as we learn about our coordinate plane. I'm going to jump a slide ahead, and I'll scroll down just in case I cut that off too quick for you. And go ahead and pause here and start copying down our one example we have for this chapter. And we're going to go through it just like we did in chapter 1, where we kind of build the equation, create the table, and then plot it on a coordinate plane. So pause here and copy down the problem. Nice. Welcome back. Okay. So I would say we need to mark up our word problem here. So I'm going to bring that problem a little closer to me because we're going to work on that extra screen over there. And the first thing I notice we care about is the word difference between John and Lauren's golf score is 2. Is going to matter. What symbol do we use for the word is? Yeah. What symbol? Not operation, symbol. Well, we're going to figure out soon. So then we want to pay attention here that it says we're going to use the letter X for John's score, and we're going to use the letter Y for Lauren's score. Okay, so now we're going to go back to that first sentence and translate it from left to right. So our first thing we have there is difference. So we know that means right subtraction. The first score mentioned was John's score, so we need to use the letter X for John. And the next score mentioned is Lauren's score, and it asks us to use the letter Y. Then we have the is. What symbol does is represent? Yep, it's an equal sign and 2. So notice we've created this equation, which kind of looks funny, so I'm going to clean this up real quick. I like how it came out that way. It should look like x minus y equals 2. Okay, that's a little more clean. It doesn't look like an underline. All right, so we created the equation first. Now we're going to create the table. And that is just going to be a simple function table where we're finding or choosing the independent variable, the x, and finding the y. And remember, in a function table, we write that function in the middle. So let's start figuring this out. And they used golf for a good reason. Is golf one of those sports that has the possibility of getting lower scores? Yeah, you could actually be under par, par usually being the 0 line. So you may say I was 5 strokes below par. And that's why they used golf, is because it can use a lot of negative numbers with it. So let's start with John's score being a 0. That means we would substitute in for the x into our function table the number 0. What number does y have to be in order for it to equal 2? That's not so easy, is it? Well, we have a minus sign, so to make a positive answer, y is going to have to be a negative number. It turns out the only answer to that would be using -2 as the y. Okay, I know, that was a hard one. I started with the negatives. Let's actually go to an easier number since we get to pick the x's. Let's jump to like 4. If John's score is a 4, what would y have to be in order for the whole equation to equal 2? Yeah, you're right. It would be a 2. We're going to make one more before we finish here. So let's go ahead and draw that. And I want you to actually choose your own value here. Remember, we're going to graph these ordered pairs, so this is probably not your best chance to choose a really big number. You just want to choose a simple one that we can use to solve. It can make a negative solution or a positive solution. That's fine. Have you chosen one? Awesome. So now on the other page that I have here, we need to draw a coordinate plane. So we're going to graph all the possible solutions for John's and for Lauren's score. I like to label these. And John's score was the x-axis, so we should label this axis John's. And Lauren's score was the y-axis, so we should label this axis Lauren. Man, my smartboard is not liking me today. Looking at our table so far with our 2 values that are close, as long as you didn't choose a third value that's really big, I think we should count by 1s. So I'm going to count by 1s on each axis. And again, you should be using the graph paper on your computer, or sorry, on your Cornell Note to make sure this is neat. Because whenever we graph, you do have to keep it equal, or else the visual won't help. So now the last part of our directions says graph the ordered pairs and describe the graph. So we're going to graph our ordered pairs. And if you have forgotten, an ordered pair gets its order from the alphabet. So we have x is 0 and y is -2. So our first ordered pair is 0, -2. We go to 0 on the x-axis and -2 on the y-axis and place a dot. Our next ordered pair is going to be 4, 2. So we go to 4 on the x-axis and up 2 before we place the ordered pair. You should have one more ordered pair on this coordinate plane when you come to class, because we should have 3 ordered pairs here. You'll know you have the correct ordered pair if the 3 dots seem to be in a directly straight line. Well, that's all we have for our lesson today. So if you have any questions, write some questions in the column, and we're going to finish up our graph here, because the one part we haven't finished here is describe the graph, and that's what we're going to do in class. So again, if you have any questions, list them in your question column, ask in class, and make sure you have that third ordered pair evaluated for. I'll see you soon.